the web, but
okay.
this video competition. So good afternoon. So we remain in the rotating CoriolisII platform, but we change environment from Antarctica to Mediterranean Sea. And on behalf of the entire team that contributed to this experiment, and the coordinator is Miroslav Gačić, and most of the team is from our institute, OGS in Trieste, and now other part of the team are, of course, from LIG Institute and from the University of Zagreb and University of Venice in Italy and University of Institute of Marine Biology in Piran, Slovenia. And actually here we simulated the change of circulation that occurs in the two-layer system after dense water injection. That was what basically occurs in the Ionian Sea, as I will show you. This is the scientific background behind the experimental setup and what happens in the Ionian. So the Ionian Sea here is in the center of the Mediterranean, is a crossroads of water masses coming from the west and the east Mediterranean. And exactly for its strategic position and for the peculiarity that is able to change sign of the main circulation in the upper layer in its northern part, is able to redistribute salt and temperature in the marginal bases that are the Adriatic and the entire Aegean Seas and the entire Levantine. That means that basically when we have a cyclonic circulation in the upper layer of the North Ionian, salty water, more salty water, and are able to enter directly the Adriatic basin. And since both the Adriatic and the Aegean Seas are places where dense water is formed during favorable winter conditions, more dense water is able to sink into the Ionian Sea. And this mechanism is able to induce reversals of these main circulation. And when the situation is anticyclonic, so pressure water from the Atlantic, that is mainly at the surface, is able to enter the Adriatic, reducing the salinity here. And this can cause changes in the density of the dense water produced, always during favorable winter conditions, that again reverse the system. Also, the Aegean Sea, in a smaller portion, contributed to this mechanism in the sense that also the Aegean is able to produce intermediate to dense water that contributed to disturb the systems. There are several feedback mechanisms in these processes, since the reversals were already observed since the 90s. But at the beginning, they were attributed mainly to the wind effect. The recent, let's say recent, because it's more or less 10 years that we are studying these internal feedbacks, were instead attributed not to the wind, but to the injections of dense water. And this was the idea behind reproducing this effect in the tank, where obviously we don't have wind effect. So some questions remain open exactly because there are large discussions on feedback and mechanisms that are able to induce such reversals, and in particular the most important was exactly if the NIG reversal, the North Ionian dry reversals, are wind-driven or mainly, as we thought, associated to internal processes, and that is injections of dense water. And another point is how slope and deep sea area differs in terms of vorticity generation when the dense water, dense outflows, comes out from the Adriatic and fill the deeper part of the Ionian Sea. And if the dense waters are the main factors, how the climatic variations that are happening in the Mediterranean Sea can influence these mechanisms. And again, there is, to understand, especially in the last 20 years, the combined effect and the competing effect between the Adriatic and the Aegean Sea in producing dense water, how they affect this kind of circulation. So we set up the Coriolis rotating platform in order to have a shape all around the tank, and we had also, this is the transverse of the scheme of the shape. Here we have a photo where you can see the shape, the circular shape all around. This is the deeper part, and we have two dense water injections, S1 and S2, where dense water were released with different characteristics, and several measurements of currents, both on the slope and the outflow of the one dense water injections, and in the center of the tank. Thanks to the release of polyamide particles in the water and with illuminated by a laser, we were able to track the movement of the particles through PIV, and then studied the vorticity and the circulation of the water within the tank. Here you can see, for example, the scheme of the laser illuminating the 12 depths within the tank, and there you can see how the outflow of dense water was working during the experiment. The dense water source was 50 centimeter wide and 2 meter length, and was supposed to release an outflow of dense water that was geostropically balanced within the tank. And here you come to the experiment, which results I want to show you now. We performed, I forgot to say that we performed an experiment in last November until mid-December, and we performed 45 days in the lab, and we performed 28 experiments, of which the last 6-7 experiments were finally the most complete, and when we gathered the most interesting results we are analyzing now. We performed the experiment in a single or double layer system and using 1 or 2 dense water sources. So here I will focus on the experiment that so far is better representing the results we were expecting from the Coriolis rotating platform, and we used a rotational time of 120 seconds to minutes. That can be considered 1 rotational day with respect to the Earth, and we used this configuration regarding the bottom layer and the upper layer, and the duration of experiment was 279 minutes, while you can find here the density property used for the upper and deeper layer, and here you can find the evolution of the experiments in terms of dense water injections. That means that one source worked for the entire experiment, releasing intermediate water of 1010 kilogram per meter square and per meter cubic, sorry, and at 0.8 liter per second. But in the last phase of the experiment, it started, at 0.4, and in the last part of the experiment, it doubled the release of dense water. In the middle, for 90 minutes, we released dense water from the source number 2 with an outflow of 1.6 liters per second and a density that was almost 1020 kilogram per meter cube. So here you have a snapshot of the results. You have the vorticity at the 2 time steps during the experiment, and the evolution of the vorticity at 3 layers surface, which includes it is an average value of the vorticity in the first 3-4 layers, in the intermediate layer, that is the green, and the bottom layer. As you can see here, the first results change the vorticity in the tank, in the upper layer, and it occurred exactly after we started injecting the dense water, the very high dense water, within the experiment after day 35, rotational day, of course. And after that, before that, we had cyclonic, weak cyclonic circulation. After start injecting the dense water, we had a reversal to the anticyclonic circulation. And when we stopped the injection of the very dense water, so slowly the system came back to, almost at last, came back to the previous situation. We probably didn't reach the previous situation because the experiment was not long enough. Here you can see the evolution of the vorticity at the surface, and the arrow indicates where the dense water was released according to the timing. And the timing is in the upper part. You can see, for example, now we started injecting dense water, and the system reacted, increasing speeds within the tank, but most of all, changing the vorticity in the upper layer of the system. And after we stopped with the second source, the first source here should disappear. The second source released again intermediate water, but at a double rate that in the beginning. We expected to reverse again the system, but the experiment probably was not long enough to reach this. So measuring the density in the central and deep part of the tank here in this region where dense water was accumulated, we were able also to see the evolution of the density structure in the upper and in the deeper layer. That is the mechanism that induces the reversal. And in particular, the inflow of dense water in the center, accumulation of dense water in the central part caused a stretching of the bottom layer and the squeezing of the top layer that caused the change of vorticity from cyclonic to anticyclonic. So the second step was to compare our results, where we saw that actually we got a change of vorticity in the tank, to compare with what happened in the Ionian Sea, where we know that is happening according to periodical changes in the circulation. And we used the data collected in winter 2012. That was a specific year in which when the Adriatic Sea produced very large amount and very dense water due to a particular and a very extreme harsh winter. It was an extreme condition because analyzing the data from several institutes and several research groups, we found that this condition happened probably only twice during the last century. And one year was exactly 2012. And by comparing the vorticity normalized by the F factor in the Ionian Sea, where we analyzed the absolute dynamic topography from satellite and from the tank that was you saw before, we obtained a good comparison of the change of vorticity. The only difference is the time factor between Ionian Sea and rotating platform. That means in the rotating factor, we have, of course, a temporal scale factor that is doubled with respect to what happened in the Ionian Sea. So we had to stretch the data with the temporal scale factor in order to compare the variability. But it's impressive how they are similar in terms of variability. And finally, another interesting aspect that I will still deeply analyze is the difference in vorticity that occurred in the central part, where we obtained the reversal from cyclonic to anticyclonic, and on the slope, where instead we observed mainly the generation of cyclonic vortices propagating along the slope. And this mechanism, here you can see, for example, the evolution of the vorticity in the central part, the red one, as you saw before, and in the slope at the surface, where you cyclonic vortices along the border of the tank. And the explanation is given by the effect of the Ekman drainage continuously causes the downslope of the displacement of the water column that generates the formation of small cyclonic vortices propagating on the slope. And the average values of the vorticity on the slope gives the positive vorticity. So in conclusions, during this ninth experiment, we observed that the North Ionian gyre vessels are caused mainly by internal processes via tube stretching, driven mainly by dense water injections, and the different changes of vorticity on the slope and in the central deep area were observed due to the combined effect of geostrophic adjustment, Ekman drainage, and vortex stretching. And the use of too dense water is useful and will be used by us to investigate the competing effect of Adriatic and Aegean dense water source to contributing to the adjustment of the circulation in the North Ionian. And another point that needs to be deeply investigated, but of course cannot be done in the tank, is the climatic effect on the bimodal internal oscillation system that is that should be studied using a large amount of real data in the Mediterranean. So thanks for the attention.
Okay. Questions? Maybe and then.
Yeah.
When you say that you have a good similarity between experiments and the field during this event, the scale is the scale of vorticity is different as well.
Yeah, the scale of vorticity is different as well, of course. The scale of vorticity is compared by scale exactly normalized by F factor that is different in the tank and in the real ocean, in the Ionian Sea. So in that case, we have a good comparison also in terms of normalized vorticity change.
So normalize the vorticity to
this is in the tank. Okay.
More generally, the key non-dimensional parameters to make
the F parameter.
To make non-dimensional parameter that to make the similarity. The non-dimensional parameters that are relevant for the similarity. You have the Rossby number, the Wood number. You investigate that.
Actually, we are still working on that. This is, of course, our preliminary comparison of the data gathered in the Ionian with those gathered in the tank.
This is for the Mediterranean research. Is there another location where this also is?
That's a good question, and at the moment we are not aware about other similar conditions all over the world where it happens. Probably to the concomitant effect of a basin that collects different water masses, fresh and saltier, from both sides, and two dense water sources that, as you know, are very limited